Let me teach you that what is hybridization. Well, the word hybridization means mixture. For example, when you mix salt plus water, you get a mixture. When you mix sugar plus water, you get a mixture. Similarly, consider two atomic orbitals, s orbital and p orbital. When these two orbitals mix or combine together, they form hybrid orbitals. Thus note it down that hybridization is the mixture or combination of atomic orbitals, just like the mixture of salt and water or mixture of sugar and water. In this lecture, for simplicity, I would often use mixture of atomic orbitals, which would mean hybridization of atomic orbitals. I do so that you could easily understand it. Hence, we define hybridization as when different atomic orbitals of same or nearly same energy combine together to form new hybrid orbitals is called hybridization. For example, the energy of s orbital is smaller than p orbital, but nearly they have the same energy, so they combine together to form hybrid orbitals. Here, you must learn that why we need to study hybridization of atomic orbitals. Well, hybridization of atomic orbitals teaches us two important concepts. It shows us molecular geometry or shape of the molecules. Secondly, it shows us the bonding of atomic orbitals. You will learn more about the molecular geometry and bonding of atomic orbitals in this lecture. Secondly, why atomic orbitals are hybridized, or why hybridization take place. Well, there are different theories which explain this concept, but I am going to explain it very easily. Consider two types of atoms, A atom and B atom. Let A atom has two orbitals, s orbital and p orbital, while B atom have only one orbital like s orbital. Now let A atom react with two atoms of B to form a molecule. We can see that there is SS bond between A atom and B atom, while here is sp bond between A atom and B atom. We can see that SS bond is totally different from sp bond. It means that A atom form two types of bonds with the same atom of B, which is impossible, not understandable, and 100% wrong. Thus, to solve this issue, we look at the hybridization of atomic orbitals or mixture of atomic orbitals. Now, s orbital and p orbital would combine together to form two hybrid orbitals known as sp orbitals. Here, this is sp orbital and this is also sp orbital. Hence, this sp orbital of A atom will form covalent bond with s orbital of B atom, and this sp orbital of A atom will also form covalent bond with s orbital of this B atom. So this is now ssp bond and this is also ssp bond. Now we can say that A atom form ssp bond with B atom, which is possible, understandable, and 100% right. Also remember that hybridization of atomic orbitals does not take place in every molecule. For example, no hybridization occurs in the atomic orbitals of molecules like H2, HCl, H2S, etc. Now let me explain the hybridization of atomic orbitals of carbon. Firstly, learning sp3 hybridization of a carbon atom. sp3 hybridization means that in this mixture of atomic orbitals, there is one s orbital and three p orbitals. So there are total 4 orbitals present in sp3 hybridization. There is 25% s character and 75% p character present in the sp3 hybridization. Now how 1s and 3p orbitals combine together to form sp3 hybridization. For example, consider a carbon atom in the ground state. We know that there are 6 electrons present in carbon atom. In 1s, there are 2 electrons, and 2s, there are 2 electrons, while in 2p, there is 1 electron in the x orbital and 1 electron in the y orbital. Now let's consider the excited state of a carbon atom. There are 2 electrons in the 1s orbital While the 1 electron and 2s jump into z orbital of 2p, this is the excited state of a carbon atom. The 1s orbital is already complete, having 2 electrons. So this 2s orbital and 3 orbitals of 2p, x, y, z mix are combined together to form 4 hybrid orbitals. Thus, I will place these unpaired 4 electrons in these 4 hybrid orbitals. Remember that they must have the same spin. This is the first sp3 orbital, this is the second sp3 orbital, this is the third sp3 orbital, and this is the fourth sp3 orbital. So we have 4 hybrid orbitals, sp3, each having 1 electron. Now it is sp3 hybridization that teaches us the geometry of carbon and its molecule. For example, carbon has this type of geometry in sp3 hybridization. This is one sp3 orbital, this is second, third and fourth sp3 orbitals, and each orbital having single electron. The bond angle in sp3 hybridization is 109.5 degree, and the shape of sp3 hybridization of carbon is tetrahedral. Note it down that these 4 sp3 hybrid orbitals are called degenerate orbitals. It means that they all have the same energy. Also, let me give you an example of sp3 hybridization of a carbon in a molecule like methane CH4. Now consider sp3 hybridization in this carbon atom. We know that there are 4 unpaired electrons present in it. According to valence bond theory or VBT, unpaired electrons are needed to form covalent bond. So 4 hydrogen atoms will share their single valence electron with the electron of hybrid orbitals of a carbon, and we get CH4. Thus, this is the shape and geometry of methane CH4 in which carbon has sp3 hybridization. So note down this example. Secondly, let me teach you sp2 hybridization. sp2 hybridization means that in this mixture of atomic orbitals, there is one s orbital and 2 p orbitals. Hence, there are total 3 orbitals present in sp2 hybridization, or there is 33% s character and 67% p character present in sp2 hybridization. Now, how these orbitals 1s and 2s combine together in sp2 hybridization? Well, again consider carbon in a ground state. We know that 1s has 2 electrons, 2s has 2 electrons, and in 2p, there is 1 electron in x orbital and 1 electron in y orbital. While in excited state of carbon, 1s has 2 electrons, 2s has 1 electron, and in 2p, there is 1 electron in x orbital, 1 electron in y orbital, and 1 electron in z orbital. Now, in the hybrid state, there are already 2 electrons present in the 1s orbital. We know that in sp2 hybridization, 1s orbital and 2p orbitals combine together. So this 2s orbital, x and y orbitals of 2p would combine together to form 3 orbitals of sp2 hybridization. Thus, I will put these unpaired electron in these hybrid orbitals having same spin. This is the first sp2 orbital, this is the second sp2 orbital, and this is the third sp2 orbital. Lastly, I write this z orbital of 2p here. This z orbital is unhybrid orbital. It means that this z orbital do not combine with 2s, 2px and 2py. Also, it has more energy than all these 3 hybrid orbitals. Now, carbon has this type of geometry in sp2 hybridization. This is the first sp2 orbital, this is the second and third sp2 orbitals. While this long orbital is the 2pz orbital, which is unhybridized orbital. These all orbitals have 1 electron each. Remember that the bond angle in sp2 hybridization is 120 degree, while the shape of carbon is trigonal. Also, let me give you an example of sp2 hybridization of carbon in a molecule like ethane. Let's consider sp2 hybridization in this carbon atom and in this carbon atom. Firstly, both the carbon atoms will form chemical bond by sharing the unpaired electrons in these sp-sp orbitals. Secondly, They both will share the unpaired electrons in the unhybrid orbitals 2pz. Then hydrogen will share its one electron with this sp2 orbital and with this sp2 orbital. Also, hydrogen will share its electron with this sp2 orbital and with this sp2 orbital. Note it down that unhybrid orbitals always form pi bond. For example, this 2pz form pi bond, while hybrid orbitals always form sigma bond. For example, these sp2 orbitals form sigma bond. Thus, in ethane, there is one pi bond and one sigma bond between carbon-carbon atoms. Hence, this is the shape and geometry of a molecule in which carbon has sp2 hybridization. So, note it down this example. Finally, let me teach you sp hybridization. Sp hybridization means that in this mixture of atomic orbitals, there is one orbital of s and one orbital of p present in it. So there are total two orbitals present in sp hybridization. There is 50% s character and 50% p character in it. Now how one s orbital and one p orbital combine together to form sp hybridization? Well, again consider carbon in ground state and an excited state. We know that in sp hybridization, only one s and one p orbitals mix are combined together to form sp hybridization. Hence, in the excited state, 2s orbital and only x orbital of 2p combine together to form 2sp hybrid orbitals. This is the first sp orbital and this is the second sp orbital. The y and z orbitals of 2p do not take part in sp hybridization of carbon. So they both are unhybrid orbitals. Thus we have two hybrid orbitals in sp hybridization, each having unpaired electron. Now carbon has this type of geometry in sp hybridization. This is the first sp orbital and this is the second sp orbital. While this long orbital is 2py and this long orbital is 2pz. They both are unhybrid orbitals. The bond angle of sp hybridization is 180 degree and its shape is linear. Also, let me give you an example of sp hybridization of carbon in a molecule like ethane. Let's consider sp hybridization in this carbon and in this carbon. Firstly, both the carbon atoms will share the unpaired electrons in sp-sp orbitals to form a chemical bond. Secondly, they both will share the unpaired electrons in unhybrid orbitals like 2py and 2pz to form a chemical bond. Then hydrogen will share its one electron with this sp orbital and with this sp orbital. There are two unhybrid orbitals like 2py and 2pz joined between carbon atoms, so there are two pi bonds present in ethane. While there is one hybrid orbital joined between carbon atoms, so there is only one sigma bond present in ethane. Hence, this is the shape and geometry of a molecule in which carbon has sp hybridization. Thus, note it down this example.